Hi, my name is Sarfiandi. So today I'm going to present about my part, which is simply supported beam F23, continuous beam 1AE and slab DE12 for reinforced concrete design 1 project. First, I will show you design location and key plan. The area that marked with the red color, it is my part, continuous beam, slab and simply supported beam. And we go to the simply supported beam F23, and this is the part where I calculate the loading analysis. And I get the value of the load is 22.67 kilonewton per meter. And I calculate the value of shear force and bending moment with the formula given. For the main reinforcement, I calculate the value of K, which is 0.182 is greater than K balance. So this means its compression reinforcement is required. So I calculate the area of compression steel, I get a 45.52 millimeter square. And area of tension steel, using the formula, I get the area is 503.88 millimeter square. This is all the required, and the provide I use 157 millimeter square to H10 and 629 millimeter square to H20. For the shear reinforcement, I use the value of shear, which is 50.44 kilonewton, and I get the VED value is lower than VRD max for the both theta. So I use theta 22 degree, tan theta 0.4 and cotangent theta 2.48. And I calculate the shear length, I got the spacing is 505 millimeter. So I calculate the max spacings, which is 0.5D, and I get 205 millimeter. So and then I continue to calculate the minimum length, and I get it's 918 millimeter. That does not comply with the maximum spacing. So I use the maximum spacing, I use HA200 along the beam. For the deflection, I calculate the rho naught, and rho prime. What I found is rho naught is higher than rho is higher than rho naught. Then I use equation 2. And it comes out that LD actual is lower than LD allowable. That means it's okay. And the cracking for the bar spacing, I get a lower than maximum allowable bar spacing. That means the cracking is okay. And this is the detail of simply supported beam F23, which is the compression is 2H10 and the tension is 2H20, and the bar and the shear bar is HA200. For the continuous beam, as you can see here, I got the span of different length. 3 span of different length, then this means I need to calculate the shear value and the bending moment manually using moment distribution method. The step of each step I use that calculate the manual, I provide in the report. As you can see here, I got the value of shear and the moment along the span. Then I can continue with. For the main reinforcement, I divide it into the part which is support, mid-span and support, and repeated along the span. For support A, I get that there is no moment, means there is no AS. There is no AS required there. For the mid-span AB, there are moments 6.55 kilonewton meter. So I get the value of AS is 29.4 millimeter square. Also same with support B, I get the value of AS is 690.12 millimeter square. This calculation and repeated between midspan BD, support D, DE, and E. For the shear reinforcement, I divided into each support and I use the higher value of shear at each support. Design shear for support A, VED is 90.3 kilonewton. And I calculate the VRD max and I found out the VED is lower than VRD max for the both theta. Then I use 22 degree, tan theta is 0.4, cotangent theta is 2.48, and I get the spacing is 1529.2 millimeter. And I calculate the maximum spacing, it's come out of 404.25 millimeter. So I use the maximum spacing to compare. It's same repeated for support D and E. Then I calculate the minimum length, and I found out the minimum length is 235 lower than the maximum. So I need to use a H6 250 as the minimum link. Then I calculate the shear resistance of minimum link, which is 125.11 kN. As you can see, there are two support here. It's over the 125 and 11 kN. So I calculate the X1 and X2 over there. For the deflection, same. I calculate the rho naught, then rho prime, and I found out that rho is lower than rho naught. Then I use equation 1. And it come out that LD actual is lower than LD allowable. That means it's okay. Same with the cracking. I found out as the S is 194 is lower than 228, which is maximum allowable bar spacing. And this is the detail of continuous beam, which is support A, B, and B, D, E. As you can see, the shear reinforcement is different for the X1 and X2 I mentioned earlier. And for the tension compression bar is also different depending on the bending moment diagram. And for the clearer, I attach this together in the full report. We continue for slab DE12. As you can see, my slab is two-way slab, so I got a short span and long span, and it is case 4, which is two adjacent edges discontinue. So I got the MX1 at midspan, MX2 at the edges or at the support, and I calculate between that. For the manual postman, I divided into short span and long span. For the short span, we have midspan and support, as I mentioned earlier, and I got the 192.66 millimeter square per meter, and same goes with the long span, same calculation and same method. For the shear, I got the short span and long span also, and for the design shear, as you can see, the VRGC is 58.31 kilonewton, is higher than VED. For the deflection also, I calculate the value of rho naught, and rho prime, and I found out that rho is lower than rho naught, so I use the equation 1. It come out that LD actual is lower than LD allowable. That means it's okay. Cracking also same, it's okay. This is the detail of slab, which is I have reinforcement, and I have a cross section AE, and I label with the numbering 0.1 until 10, and for the clear I attach together and at the report. Alright, that's all from me. Thank you.